Good morning, class. We're still looking at slope, and we're looking at slope as rate of change. The essential question is, how do I find and apply slope? Your learning intention, I'm learning to apply slope as rate of change in real life scenarios. So you've got three warm-up questions. Solve using the quadratic formula, find the slope of the following between the 2 points, and then find the slope from the graph. So pause the video and see if you can complete these three warm-ups on your own. Well, I hope you tried. So on the first one, step 1 is to identify A, B, and C. A is equal to 2, B is equal to -8, and C is equal to -7. Okay, now I've got to find that discriminant and then square root my discriminant. So my discriminant is b squared, -8 squared, minus 4 times 2 times -7. 4 times AC. So, putting it all into our calculator, we find that the answer is 120. Now 120 is not a perfect square. So we're going to still take the square root of 120, but we're going to do that long division. We know it's divisible by 2. 120 divided by 2 is 60. 60 is divisible by 2. 60 divided by 2 is 30. 30 is divisible by 2. 30 divided by 2 is 15. 15 is not divisible by 2, but it is by 3. So I get 3, I get 5. 5 is prime. Divide by 5. When you get to 1, you're done. Now, square root means we're taking 2 of a kind. If you notice, we only have a pair of 2's. So this is equal to 2 square root of 30. And that would be positive or negative. So let's finish it up. The opposite of B. B is -8. So this is 8. This time we'll just make it as one equation. 8 plus or minus 2 square root of 30 all over 2 times 2. Do I have any common factors? If you're looking, everything is divisible by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. 2 divided by 2 is 1. So this ends up as 4 plus or minus the square root of 30 all over 2. And we're done. We've created one equation, and that's good. Okay, do you remember the formula for finding slope? Finding slope is the difference of y over the difference of x. So identify x, y, x, y. So my slope is the difference of y over the difference of x. 15 minus -7 over -10 minus 1. Okay, 15 minus -7 is the same as 15 plus 7, which is 22. -10 minus 1 more is -11. I can simplify that to -2, and I'm done. Okay, from a graph, we're looking at rise over run. We're also looking at the fact that we'll create that right triangle. Okay, it's a negative slope, so I'm going to put negative first, and I'm going to count down. 1, 2, 3, 4, 5. I go down 5, and I go right how many? 1, 2, 3, 4. And I'm done. So on the first one, you apply a formula. The second one, you apply a formula. The third one, you count. So a blank, 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 blank describes the slope or steepness of a graph, or how fast the two qualities change. So this is the constant rate of change. So the constant rate of change is the slope, it's the steepness, however you want to describe it. So a lot of what we're looking at today deals with word problems. The owner of Fabulous Fitness wants to buy name tags for her staff. She writes the following linear function to represent the cost y for the quantity of name tags x from an online vendor. Y is equal to $2 times x plus 7. What is the rate of change and what does it mean? If we're looking at rate of change, if we're looking at slope, this is in y-intercept form. Our slope is what? Our slope is $2. What does that mean? Well, it means that each of the name tags will cost $2. What is the initial value and what could it represent? The initial value is $7. What could it represent? Well, it could represent the shipping and handling. It could represent the setup fee. It could represent anything that's not going to change. A $7 shipping and handling fee is pretty cheap anymore. Okay, if she has 38 employees besides herself, how much would the names tags cost? So we know that X will be what? Okay, 38 employees plus herself would give me 39. Now that I know what X is, what am I going to do? Well, my total cost is equal to $2 times 39 plus $7. So, what does our calculator tell us? So after you get it into the calculator, you end up with 85. So the cost of those name tags for her and her staff would be $85. This function representing the cost of the name tags purchased is shown in the graph. Complete the coordinates of the points shown on the graph. 10 something. So we know this is the function y equals $2 times x plus $7. Am I going to be able to look at that graph and tell how much it is at that point? No. So what do I need to do to figure it out? Well, I'm going to use substitution. Y is equal to $2 times 10 plus $7. Okay, $2 times 10 is $20. $20 plus $7 is equal to $27. So this would be 27. I can't get it off the graph, but I can get it by using the equation. What does it mean? What does that point mean? The cost of 10 name tags is $27. Okay, how many of you want to buy a car? Well, even if you get a brand new car, guess what? You have depreciation. So the following table shows how the value of a new car depreciates or decreases over time. So when you start out 0, 24,000, 1, 20,000, 2, 18, 3, 17, 4, 15. What does it mean? What is the purchase price of that car? Well, it's $24,000 before you buy it, drive it off the lot. Okay, calculate the slope using the 2 points, 120 and 317,000. 120,000, 317,000. So remember, our slope is delta y over delta x. These are our x values and y values, x values and y values. So y minus y, 20,000 minus 17,000 over 1 minus 3. Okay, what is 27,000 minus, or 20,000 minus 17,000 gives me 3,000 divided by 1 minus 3 is negative 2. So what is half of 3,000? 1,500. So this is negative 1,500. So if you're looking at it, between those 2 years, between year 1 and year 3, you've lost $3,000 in the price, the value of your car, which shows a decline of $1,500 per year. So let's see what happens between 3 and 4. Let's see if this is a linear equation or not. Once again, identify x, y, x, y. And we've got 17,000 minus 15,000 over 3 minus 4. So 17,000 minus 15,000 is 2,000 over negative 1, which is negative 2,000. So between years 1 and year 3, you lost about $1,500 a year. But between years 3 and 4, you lose $2,000 in value in the year. So what do you notice? As the car gets older, the rate of depreciation increases. This is not a linear function. So, if you want a new car, that's fine and dandy. You get a lot of benefits, like a year where they'll take care of anything that goes wrong. But the minute you you drive it off the line, you have depreciation. So even if you take it in the next day to trade it in, it will not be worth as much as you paid for it. Doesn't sound right, but that's kind of the way it is. So remember that depreciation is not linear, and it will start decreasing more and more as the car gets older. So how do you know when you're successful? I know when I'm successful that when I can apply slope as rate of change in real life scenarios. So this is we're interpreting slope, what it means.